Today's objective is to be able to prepare for our unit exam by completing some review questions. On Thursday, you'll be completing your first exam in algebra. This task will help you prepare for the exam, and these are the following topics that will be covered in the exam. It includes exponents, square roots and perfect squares, rational versus irrational numbers, how do we evaluate expressions, and solving all types of equations. We'll review some examples here that will help you prepare for that exam on Thursday, and then for your task, you'll answer additional questions that will also be very similar to the things that you'll be seeing this Thursday. So this example says, if the area of a square is 49 inches squared, then what are the measurements of the sides of the squared? Now the first thing that I know about a square is that all sides are the same. So I know that if I know how big this side is, then I also know how big this side is, I also know how big this side is, and I also know how big that side is. That's one thing I know. I also know that if I want to find the area of a square, then I need to take one of its sides, however big it is, and I have to multiply it to itself in order to figure out what the area is. In other words, I need to take my side length and I need to square it in order to figure out what that area of that square is. Well, in this case, we're working backwards. We want to figure out, okay, if my area is 49 inches square, then what do my sides have to be? What number can I square in order to give me a value of 49? Well, when we're working backwards from squaring something, the inverse operation of squaring something, or the backwards operation of squaring something, is taking the square root. So if I square root this 49, that's going to give me 7, which means that because 7 squared gives me 49, which means that the sides of this square are 7 inches long. And that means this is also 7 inches, that means this is 7 inches, and that also means that this is 7 inches. Once I find one side of my square, then I know already what all the sides measure. And I can use that information to figure out any other operation that has to do with the sides of my square. So this example says, is the number 5.323232 with 3 little dots rational or irrational? Now 5.323232 with 3 little dots means that this number is going on forever, but it's going on forever with this pattern. Okay, and the pattern here is that the 32 is repeating itself over and over again. Now another way to rewrite this number would just be 5.32 with a bar on top. Okay, so I know that either of these two things mean the same, and I know that any number that has a pattern, that repeats itself with a pattern, is a rational number. So that's one thing I can say. I can say this number is rational because it's a repeating number, a repeating decimal with a pattern. However, what if I don't remember, what if I can't recognize whether that number has a pattern or not? Well, the best thing that you can do is to always use your calculator to always double check whether you can turn this number into a fraction or not. That is the best way to tell whether a number is rational or irrational. If you can't tell by looking at the decimals, if you can't tell by looking at the patterns, then you must always use your calculator to make sure that you know how to figure out whether that number can be written as a fraction or not. Now I want to check if this number is rational or irrational using my calculator by checking if it turns into a fraction. Now the most common mistake is that when students see a repeating decimal, they're only going to write what they see on paper in the calculator. So they're going to either write 5.32 or they're going to write 5.323232, which is what we saw on paper. However, if I try to turn this into a fraction, that's actually going to give me the same thing back, which then is going to tell me that it's an irrational number. However, remember that the 3 little dots written on our paper, or the bar on top written on our paper, tells me that that number actually goes on forever. So in order to change that number into a fraction, I have to add a lot of 32s, many of them, to show my calculator that this is a repeating decimal. And now that I've added many of them, now I can check whether this turns into a fraction or not. So I'm going to go to math, I'm going to go to fraction, And now I see that I get a fraction back, which lets me know, as I mentioned before, that this number, 5.32 repeated, is actually a rational number. So this says when x is equal to -4, what is the expression x squared minus x plus 2 equal to? Now the first thing that I'm going to do is, before I start doing anything with evaluating, is make sure that any variable that doesn't show its coefficient, I'm going to give it a coefficient of 1. So I have a 1 here, and I have a 1 here that becomes a -1 because there's a minus right before it. So now I can start replacing my variables with my parentheses. So I have 1 parentheses, and in that parentheses I'm going to put my -4. Now remember, all exponents always go outside of your parentheses. Now I continue with -1, again parentheses, -4, and I finish off with my plus 2. Please always make sure that you're including every single part of your expression. Sometimes you might see an expression and some students are evaluating just a part of it and forgetting the thing that comes at the end. We're evaluating the whole entire expression. So now, when I tell you guys to show your work for a problem like this is all you need to do. All I want you to do is take this expression, show me how you're replacing the variable with your parentheses and your coefficients, and then all I want you to do, I do not want you to start doing what's -4 times -4, then times 1. I don't want you to do pieces by pieces because it's very easy to make simple mistakes. What I want you guys to do is, once you have this on your paper, all I want you to do is put this into your calculator and then give me the value that you get. And when I place this into my calculator and I write it exactly like what I see it here, I get a value of positive 22. This problem is just another equation that we need to solve, very similar to the last lesson that we did on solving equations with variables on both sides. Now the first thing that I'm looking for is my two couples. So I have -4x as one of my couples, and I have positive 2x as my other couple. Now, my goal right now is to make sure that my couples are all on one side of my equation. I do not want to have couples on both sides. So I'm either going to bring this -4x over here, or I'm going to bring this 2x over here. Neither of those things are wrong. Both of those things are correct steps to take. What I'm going to do is I'm going to take my smaller couple, in this case the -4x, and I'm going to bring it to the 2x. Now this is a -4x, so in order to bring it to the opposite side, I have to do the inverse operation, or the opposite. So I'm going to add 4x here. And remember, we can only add couples with couples, not with side chicks. So now this -4x plus 4x will cancel out. I'm going to bring down my positive 9. I'm going to bring down my equal sign. 2 plus 4x is 2x plus 4x is going to give me 6x. And I'm going to bring down this -21. Now here I can start identifying who my couple is, who my new couple is, and who my side chick is. Now my couple here is going to be the 6x, because again, they're the two things that are being multiplied. They are the two things that are married with each other. So this is going to be my couple. And then my side chick is going to be the same thing that's on the same, is going to be the thing that's on the same side of my couple, which is this -21 here. Now once I figure out who my side chick and my couple are, I can go ahead and get started, and I can go ahead and start getting my couple alone. Again, we want to get, our next goal here is to make sure that our couple is alone. We don't want anybody on the same side of our couple. So we're going to go ahead and get rid of our -21. Now the opposite of -21 is +21, so I'm going to add 21 on both sides. This is going to give me 30. I'm going to bring down my equal sign. I'm going to bring down this 6x that I haven't touched here, and these two things will cancel each other out. Now the last thing that we always want to do here is to make sure to divorce our couple. So we'll be dividing by its coefficient. And we get 1x is equal to 5. Now remember that if I ask you to check your solution in your problems or in your exam and you do not check, you will be losing credit. So if I ask you for a check, you must show check in order to receive full credit for those problems. A lot of students in their last independent practice show me the correct solution for the equations, but they didn't receive full credit for those questions because they did not show me how they checked their answers. So make sure that you're following all parts of the instructions when you are answering the questions in your exam. So we're going to go ahead and check here. So we have -4 parentheses 5 plus 9, and we're going to check what that gives us. And we have 2 parentheses 5 minus 21, and we're going to check what that gives us. And when I plug these two things into the calculator separately, you'll see that they'll both give me a value of -11. So these are just some of the types of questions that you'll see in your exam on Thursday. So make sure that if there's anything that you do not understand in these questions or these examples, or anything that you don't understand on your task, that you are joining us for tutoring today, asking questions and getting any clarification, so that on Thursday there are no misconceptions.